like if you go back to passage 1, you were working on that like an hour and a half ago. Like you're not really going to remember a lot of that. And like switching the answer at that point is probably going to be more likely to hurt than help.
Phil, back for some more MCAT podcast, wrapping up Chem Phys from full length 1, blueprint full length 1. I'm ready to get through this.
Yeah. I'm a little bit sad. I'm definitely a physics, chemistry kind of guy. Last week we did our last passage, which was the fluid dynamics passage. Now we just got a couple of discrete questions. We still got some physics stuff going, so I'm still okay.
Okay, good.
I'll survive.
All right, let's rock and roll.
All right, so last discrete set here. We start off with actually kind of a doozy of a question. So we have a child with a sliding toy block with mass m, and sliding the toy block down the ramp. The coefficient of static friction between the block and the ramp is 0.25. When the block is halfway down the ramp, the child pushes down on the block perpendicular to the plane, halting it. They want to know what's the minimum force that the child must apply to keep the block from starting to slide down the ramp. And so the answer is mg sine theta. 0.25 mg cosine theta plus mg sine theta, mg sine theta minus 0.25 mg cosine theta, and then the quantity mg sine theta divided by 0.25 minus mg cosine theta.
Yeah, that's an easy question, right?
Yeah, piece of cake. Luckily, I know a lot of people are going to look at this and be like, oh, that's so awful, and they look at the answer choices and that seems, but I think that it would be harder if the answer was like 0.7. Or like if they actually like gave us a number here, because then we would have to calculate stuff out. Now we just have to figure out how to arrange the equation to solve for whatever we're trying to solve for.
Yep.
And then once we figure that out, we don't actually have to do any math. We just have to figure out how to arrange it.
Yep. So mg, I'm assuming is just mass times gravity.
So it's going to be the force of gravity pulling it down.
Yeah. Theta is the angle of the ramp, which is 45 degrees here in this drawing. Again, doesn't really matter because we don't have numbers.
Yeah, that's exactly what I was going to say. Like they could have said it was 17 degrees or 190. It doesn't make a difference.
Yeah. And so the question comes down to knowing the equation. Does the coefficient of friction matter in the equation or not, right? Because the answer choice A is just mg sine theta, which the coefficient of friction isn't built into that. My assumption is that, of course, coefficient of friction matters because that's the whole point of these silly ramp questions. It's all about the coefficient of friction.
I mean, if the friction was high enough, the kid wouldn't have to push down at all. It would just stop on its own. And so it's obviously going to play some role in this.
Yep. So already I've lost one, so I'm down to a better chance of getting this question right. So we know that the 0.25 has to come in here at some point. And now the question is the cosine, sine, how does all of that work? So I'll let you explain.
Yeah. So I definitely want to use my scratch paper on this, on test day. I mean, you have scratch paper, you want to utilize it if you can. And so I'm going to recreate this drawing and I'm going to start to add in all of the relevant forces.
And just a clarification, as for scratch paper, you mean this silly wet erase packet that they give you?
The weird, funky laminated notebook with the markers that come with it. Yeah. So as you're like writing on your laminated, funky notebook, you'll note that you have a couple of forces. There's the friction force, which we already mentioned. That's going to be holding this onto the ramp. There's also going to be a force pulling it down the ramp, like in the opposite direction. And that's going to be due to gravity. That's going to be mg sine theta. I always think sine for sliding. And so the one that's going down the ramp is going to be the sine. And we know that like the force of, if this kid's holding it stationary, that force of friction has got to be equal to the force, or the mg sine theta. So I already have like a good relationship here. Mg sine theta is equal to the force of friction. Now, the other forces that we have going on here, in all classic, inclined plane questions, we're going to have gravity pulling it into the plane, which is going to be mg cosine theta. And then there's going to be a normal force that's going in the opposite direction. Now, under normal conditions, that's pretty much it. However, we got this kid here who's pushing this block into the inclined plane. And so that's an added force pushing it into the plane. And so because this object is not like smushing into the plane or rocketing off, we know these forces all have to be equal and like cancel out. And so we know that the two forces going into the plane, the force of the kid pushing it and the force of gravity, mg cosine theta, those added together are going to be equal to the normal force. So normal force is equal to mg cosine theta plus the force of the kid pushing. Now, because we're trying to solve for this force of the kid pushing, I'm going to rearrange that equation. I'm going to say the force of the kid pushing is going to be the normal force minus mg cosine theta. And so that's good. So now the problem is just like, how do we, like, there's no normal force in these equations, right? There's nothing we can kind of like do with that. So I need to get rid of this normal force. Luckily, those of you guys who are masters of friction understand that the force of friction is equal to the coefficient times the normal force. And so we know that the force of friction is equal to mg sine theta. We also know that that's equal to 0.25 times the normal force. So that means that the normal force is equal to mg sine theta divided by 0.25. And that is the normal force. So if we go back and we know this force of pushing is the normal force minus mg cosine theta, and we know that the normal force is mg sine theta divided by 0.25, then the force of pushing has got to be mg sine theta divided by 0.25 minus mg cosine theta, which is going to be D.
And that would all make sense on your sketch paper.
Yeah, definitely got to draw this one out. This is not a question that I would recommend trying to do it in your head. Even if you're completely lost, start to fill out the drawing. And as we've been kind of like talking about the last couple of weeks, if you like start to draw it out, and then you'll just be like, well, these two have to be equal, and well, these two have to be, or these three have to be equal to each other. And eventually you can kind of like solve for and figure those things out. I also really like your initial gut response of just like, well, what can I figure out? Well, the friction's going to matter. So A's out. And so you've like drastically improved your chance from like a 1 in 4 to a 1 in 3. And you haven't really done anything other than just know friction matters. If this inclined plane is covered in ice or sandpaper, there's going to be a difference in like holding it up onto the plane.
Yeah.
Yeah.
There you go. Moral of the story, friction matters.
Yeah, friction matters.
It's a good t-shirt.
Yeah.
All right. Yeah, so that's definitely know your equations there.
Yep.
Relationship
so
to
luckily
everything.
the other two questions are a little bit more less requiring you to write out and do math.
All right, hopefully.
Yeah.
So question 58, Tucson, Arizona is well known for its sunny, dry weather. A 33 degrees Celsius day in Tucson can feel relatively cool and pleasant compared to a similar temperature in a humid city like Tampa. The phenomenon of, quote, dry heat, feeling subjectively cooler, is a result of, I think I know this one. A, decreased evaporation from the skin helping to keep the body cool. No. B, increased evaporation from the skin helping to keep the body cool. Yes. C, decreased cardiac output in response to dehydration, lowering cutaneous perfusion. That's ridiculous. Or D, increased cardiac output in response to dehydration, lowering cutaneous perfusion. Those don't make sense. So the answer choice is B.
Yeah. So just evaporation, like as water goes from a liquid to a gas, it's an endothermic reaction. So it absorbs energy. And so it absorbs heat from you. And so it makes you feel cooler.
Yeah.
I like C and D. That's like, you're having a heart attack or something. Like your heart quit's working and that's why it's cooler. And it's like, well, maybe it's cooler because you're dead, right?
Yeah.
C and D don't make any sense.
Yeah. I mean, it just physiologically, right? When you are dehydrated, your cardiac output does go up because your heart rate's going up to potentially to get blood going, but that has nothing to do with cutaneous perfusion or not, because your body's going to shunt blood where it needs to go anyway. So it just doesn't make sense. All right. See, being a doctor helped me answer that question. All right.
Yeah, there you go. So maybe it might help this one also.
All right.
So 59, vinblastine is a microtubule disrupting drug that inhibits tubulin polymerization. I don't know if this will help. You got to have some like anti-cancer knowledge here for sure, specific. Which of the following processes would be directly inhibited upon vinblastine treatment? So once again, another Roman numeral question. We got phagosome transport to the lysosome. Roman numeral 1. 2 is mitosis. 3 is meiosis. 4 is electron transport. And then we have a whole slew of different answers. 2 only, 1 and 4 only, 2 and 3 only, 1, 2, and 3 only. I feel like that should just be not 4.
Yeah. Not 4. So 4 stands out to me because electron transport just doesn't make like it's which one of these is not like the others, right? And so electron transport just to me doesn't seem like it's the right answer. So again, I try to like how can I increase my odds? So I go from 25% chance to a 33% chance, I think.
Mm-hmm. Yep.
And then I remember tubulin. Tubulin is like this little structure thingy that helps things move and do stuff. And so it seems like all of the other choices would use tubulin potentially. And so I would go with D, 1, 2, and 3.
Yeah, absolutely. Tubulin, we make microtubules out of it, which are like the little highways inside the cell. So that's how we move stuff from the Golgi to the lysosome and vice versa. So moving phagosomes after we like phagocytose something to like move that to the lysosome, those little highways are probably going to be useful, which are made from tubulin. Also, just side note, mitosis and meiosis, they're pretty similar, right? Like, and so just off of that, even if I'm like, once again, really lost, if it's something's important for mitosis, it's probably also important for meiosis, which means that it's either 2 and 3 both or not 2 and not 3, right? Because they're so similar. And so using that with what you were saying about the electron transport, that gets you to a 50-50. You're like C and D. And so even if you have no idea what's going on with tubulin, you know mitosis and meiosis are similar and electron transport's weird. You're down to a 50-50. Yep. And so in mitosis and meiosis, you do use microtubules to push and pull the chromosomes during like metaphase, pushing them onto the metaphase plate, and then in anaphase as you pull them apart. That's still moving things around inside the cell, and so that's where tubulin comes in. Because tubulin messes with mitosis or cell division, that's why this is used sometimes as a anti-cancer medication, because it makes it difficult for cells to divide and split, which is important for a cancer cell.
But you're doing that often.
Yeah.
Okay, so 2 out of 3 ain't bad. I'll take that for a discrete set. Yeah. So that's the end of Chem Phys. Let's talk just briefly as we wrap up. At the end of a section, what should a student be thinking before moving on to the next one?
Well, I mean, first off, if you got some time left, maybe go back and relook over some stuff. Like if you like finished it and you still have like 10 minutes. I don't encourage students
because that's always a common thing.
Yeah. I don't encourage students to like go back to passages that often, because like if you go back to passage 1, you were working on that like an hour and a half ago. Like you're not really going to remember a lot of that, and like switching the answer at that point is probably going to be more likely to hurt than help. But I do think it's important to just kind of, like be thinking about like the next step. And just kind of like take a deep breath. After this, we're going to get a 10-minute break. Absolutely use it. Always use it. Use the whole 10 minutes. I don't care if you don't have to go to the bathroom. Get up and go to the bathroom. Like stretch your legs. There's a lot of students that want to like, I just want to be done. And they just want to like be like, down there working, shackled to the desk and like neck cricked, and they don't need to come up for air. That's going to make it harder. Moving forward.
I did that on step 2. I just sat through the whole thing. No breaks, no lunch. Step 2, I just like get it done. I did very well, so thankfully it worked for me. But very different test than the MCAT.
Right. Yeah. And I also think that that's important because, as we've like talked a lot in this section, so much of this, like even if you're not sure what to do, even if you're a little bit lost, you can still figure your way to an answer. And that sort of like critical thinking skill is very important. I'm not saying you don't need to know anything, because obviously there's a lot of content you need to have mastered as well. But even if you've mastered all the content, there's still a lot of like figuring and like weighing and like, finagling your way into a correct answer or towards a correct answer. And that sort of thing tends to become difficult if you get a little burnt out and fried and exhausted. So it's another reason I really encourage students to, get up, stretch their leg, take that break, and then, get ready to buckle back down for cars. I also think it's especially important to make that change because as we're coming out of the Chem Phys section and going into cars, like the landscape is changing drastically, right? Like the cars passage is completely different from all the other sections.
Yep.
And so you need to kind of like prepare your brain, like switch gears,
Yep.
right? So that you're ready to tackle the challenges that are coming up in the car section. I know a lot of students get a little freaked out by the Chem Phys. It's probably generally it's one of the least favorite. It might be cars for a lot of students, but a lot of students also hate chemistry and physics. They aren't in love with it as maybe we are. But I think it's nice to like get that out of the way first. I can't imagine doing a lot of complex calculations after I've already been sitting and working hard for 6 hours. Like I'm probably going to be more likely to make little silly errors. So I kind of personally like having Chem Phys first, just because that's when my brain is freshest, and that's maybe when I need it the most. Putting all those math things together.
I wonder if there's any logic that goes into the order of the tests and the sections.
I honestly feel like maybe there is, or there should be, or maybe it's just like hindsight bias. But I definitely feel like of all the sections, psych is a lot more just like, do you know these terms? Do you know the vocab? And if you do, you do well. If not, then you do poorly. Yeah. And so having that at the end, I think is a blessing, because that's maybe a little bit less mentally intensive than some of the other sections.
Yeah. All right. Chem Phys. Peace out.
Yeah, we'll be coming back for cars.